Welcome to Chibuzor Mathphysics. In this video, we shall be dealing with lemma. In the previous video, we talked about theorems. And I told you that a theorem is a mathematical statement that is proved using rigorous mathematical reasoning. In today's video, we shall focus on what is lemma. Lemma is a minor result whose sole purpose is to help improving a theorem. Now you can know of the relationship between lemma and theorems. What did lemma has to say? Lemma affirms that between any two rational numbers, there always exists a third rational number. So what is the theorem behind this statement? The theorem behind this statement is that there does not exist a rational number r such that r squared is equals to 2. In other words, what we are saying is that r is equals to root 2. And we know that root 2 is not a rational number. It is irrational. So we can go ahead now to prove that root 2 is irrational using lemma. So we say that suppose on the contrary that r is equals to root 2 is irrational or is rational on the contrary, because we are proving that root 2 is irrational. If root 2 is rational, it implies that root 2 can be represented in the form of m over n. And we know that m and n can only be equal to 1. N cannot be equal to 0, because if the denominator is equal to 0, it is undefined. To remove the root sign, we square both sides, so that we have 2 is equals to m squared over n squared. This implies that m squared is equals to 2n squared. Cross multiply. But if you observe here, you will notice that m squared is an even number. If m squared is even m is also even. That is to say that m is equals to 2k. If m is equals to 2k, we can see from m squared, which is equals to 2n squared, now we can represent into 2k squared. Let us clear this. We are saying that m squared is equals to 2n squared, which is equals to 2k squared. So we can have 2n squared is equals to 2n squared. This implies that 2n squared is equals to 2m squared, which will give us 4k squared. So n squared is equals to 2k squared. N is also even. If m is also even, it means that mn is not equal to 1. Hence, root 2 is irrational. And this is how we prove that a theorem or that a rational number, some certain number, is irrational. So we know by this proof that root 2 is irrational.